Hello, this is Mark Isselhart, Maple Specialist with UVM Extension. I'm going to be presenting Is It okay to Tap Below the Lateral Line? This is a presentation based on work done by Tim Perkins at the UVM Proctor Maple Research Center and others. And the topic is really to look at whether or not sap yields are impacted by tapping below the lateral line, which for the most part is a unconventional method of tapping. Most maple producers, the goal is to maximize how much sap you get. If you go through all the efforts of tapping and producing maple syrup, which are considerable, you want to be able to get the most yield you can from those taps. At the same time, you want to make sure your crop trees are staying healthy for the long term. So that's sort of a two-pronged need for most producers. We all know the reality is that you need to make a new tap hole every year, and that does create a bit of a wound in the tree and has some impact. And the reason for that is because the tree has a natural process of defending against systemic infection called compartmentalization. So we need to make new holes every year. So when you think about it, tapping is drilling a small hole into the stem of the tree. That's the xylem tissue. That's the tissue that during the growing season, water is being sucked up from the ground through the roots, through the stem, and out the leaves during photosynthesis. It's that same tissue we tap into during the sugaring season to collect the sap. The functional wood, the sap wood that can actually produce sap, is a lighter color. The wounds that have been made either from a tap hole or perhaps from a broken branch and that sort of thing will become non-functional and will become darkened. It'll be stained as part of the tree's natural defenses. Tapping can create a wound, obviously, and the tree compartmentalizes this wound. It has a harder time compartmentalizing in the vertical direction, both above and below the tap hole. So the staining extends much more in that direction versus side to side. It's important to realize that this stained wood will not produce sap in the future. The size of that wound, the size of that non-conductive tissue that you create by tapping into the tree is a function of both the diameter of the tapping bit and the depth of the hole, how deep you go, and to some extent how far away you are from a previous tap hole. And that is not so much an exact distance, but whether or not you intercept an old tap hole. The number of areas, the number of compartmentalized areas, is another way of defining the tapping intensity. So in other words, if you put 2 holes in a tree, you're making twice as much staining. And it has real impacts both for sugar production, sap production, and for tree health. So with a very high level of tapping intensity, like you might see here in this crosscut of a tree, you can end up with areas that are of the tree that have kind of died. You see this most often when people are cluster tapping or following some maybe some old folk wisdom of always tap on the south side of the tree because that's where the sap is most, or under a big limb or over a big root. These things really don't have a lot of truth to them, and even if they did produce slightly more sap, you'd quickly kill that part of the tree by cluster tapping. So you want to make sure that new tap holes don't intersect old tap holes, because the combination of those two can make for even larger stain. And you can also increase the amount of heartwood going into being formed in the tree. When you have a high tapping intensity, it's also hard to find good clean wood to tap into, and this, as we'll see, has a big impact on sap yield. It could potentially, if there was a high enough rate of tapping intensity, there could be an impact on the tree's ability to transport water during the growing season, but this hasn't been very well researched. Potentially you could have loss of vigor and reduced tree growth, but we are actively researching that at the Proctor Maple Research Center, and please look at some other publications on that subject to learn more about it. if we were doing a long-term project, trying to eliminate other variables and just look at the impact of tapping on tree growth. So at the end of the day, it's important to try to balance the wounding and the needs for sap yield. When you're out there tapping, it is important to look to see the chips that are coming out of the tap hole. The chips on the left are really what you're looking for, that creamy white color. They have a little bit of a spring to them. They're clearly good conductive tissue. The ones on the right are brown, and they represent very little or no sap flow would come out of that tap hole. So it's important. It's an exciting time. There's a time when there's a lot of help, but it can also be a time when you make mistakes by tapping into old tap holes. So take your time, look at it, and you should really make sure you're looking to see how often you're hitting brown wood, if at all, and adjust accordingly. There are a lot of factors that go into whether or not you're going to hit stained wood, and a lot of this work is described in papers done by Dr. Abby Vandenberg at the Proctor Maple Research Center. She actually has an online computer model where you can tap in, plug in, a bunch of variables such as how fast your trees are growing, how big the tree is in diameter, how long your drop lines are, all these things. They can impact the sustainability of your tapping practices. So let's just take drop line length, for instance. If your drop line is only 3 inches long, which certainly is not something that people would do intentionally, but say it was only 3 inches long, the area that you can realistically tap with that is very small. And so year after year, your tap holes will be going in that same area. The tree is only growing so much each year. And very quickly you would start hitting old wounds. So you need to balance the drop line length with how big the tree is and how far away you can get from old tap holes. This tapping zone model is available on the Proctor Maple Research Center website, and I will put a address at the end of this presentation so you can check that out. So one of the reasons why we started this work was that we were finding issues at the Proctor Center when we were tapping our production bush. We were finding that especially in some of the older sections where the trees have been tapped for a very long time, we were hitting stained wood much more frequently than we would have liked. In fact, in some years we were over 10% of the time we were hitting stained wood. And this is despite the fact we were using relatively shallow tap holes and using smaller diameter spouts, so 5/16 of an inch. So in the year 2000, we made the choice to go to just one tap per tree, regardless of diameter, and it does seem to be helping quite a bit. So things you can do to address it: use small spouts, longer drop lines, use fewer tap holes on the tree, and shallower. Those things will all impact the tapping intensity. And you also want to be making sure these trees are growing, so making sure they have some room to grow. You don't want to overthin, you don't want to shock these trees, but releasing one or perhaps even two sides of the crown of a crop tree every so often, 10 to 15 years, can make maximize the amount of wood growth, because it's that wood that you're growing each year that is making up for what's being removed or functionally removed as a result of tapping. If the trees are really densely packed in and limited for light, they're not going to put on very much wood. It's going to take much longer to accumulate enough wood to make up for where you are putting in tap holes. So one of the questions is, how can we overcome this? And short of turbocharging the growth of trees, one way is to just increase the size of the tapping band. And by tapping band, I mean the area where we can reach with our drop lines. Of course, this is limited by your ability, how tall the person is who's doing the tapping, and the snow in any given year. But we looked at what are ways that we can increase the size of that band. So this illustration kind of shows what we typically expect to see in the woods. We see a lateral line and a drop line always going up. But how come we don't see more of this? And I think everyone would admit that this looks a little bit strange, and if you were to see a producer tapping like this, you might question how long they've been doing it, and might give them some friendly suggestions about how to do it. But we wanted to look to see, what is the impact of tapping in this way, because essentially you're doubling the size of the tapping band. Sugar makers have expressed concerns that you might get less sap per tap if you were to tap below the lateral line, and that there might be issues on sap quality. Either the sap isn't coming out of the lines fast enough and could be potentially contaminated and make for off-flavored syrup. So all those concerns were expressed. And equipment limitations. Is there an issue? Is there a level of vacuum you need in order to overcome that height difference, or can most pumps handle it? So in 2015 and 2016, the Proctor Center received money from the North American Maple Syrup Council, who helped sponsor this study, and was whether or not there's a negative impact on sap yield when tapping below the lateral line. So theoretically, we might see some reduction because you're having to pull it up above or against gravity, and there's less head pressure, and there might be some issues with sanitation in the tap hole and spout. So to describe the experimental design, these are large, mature trees growing at the Proctor Maple Research Center. The average diameter was just under 18 inches at DBH, and we had 30 to 33 trees in this study. 10 of them were tapped in a conventional way, above the lateral, new spouts. 10 were tapped below the lateral, again with new spouts. And a third treatment was done. That was 10 were tapped below the lateral with the check valve spouts. All the drop lines were the same. They were all new. They were 5/16 of an inch diameter tubing, and the drops were 24 inches. And I'll point out that 24 inches is not our recommendation for drop line length. We think 30 inches as a minimum, but given that this study was limited in the amount of time that we'd be doing it, we decided to go with a slightly shorter drop line. All trees were tapped on the same day and were tapped 2 inches deep with 5/16 inch spout, and they were all combined to a common vacuum pump at around 25 inches of mercury. In the picture on the left, you can see one pair of those trees, and you can also see the blue vacuum chambers. So those are large chambers that can hold 40 gallons of sap at a time, and they are under high vacuum. So we have individual tree data from each of those trees in each of those 3 treatments. We clicked the sap into those vacuum chambers, and we calculated and measured sap total volume and sap sugar content at the end of each season, 2015 and 2016. Here's an example of a pair of trees. The tree on the left clearly is tapped below the lateral, and the one on the right is tapped above. And I'll point out that the spout is upside down in this scenario. So we didn't, in other words, have the spout with the barbed part of the spout pointed down and then looping up. It's just going straight up into the lateral. So at the end of the season, we measured sap depth and we measured sap sweetness, sap sugar content, which allowed us to make a calculation for potential syrup produced per tree. Now I'll talk about the results. So when we looked at the 3 treatments, tapping again above, tapping below, and tapping below with a check valve, we found that there was no significant difference between those 3 treatments. Now, as you see the bar on the left, tapping above with no stain, those are trees that no stained wood was intercepted when we tapped into the tree. Unfortunately, we did hit some stained wood. So those stained wood individuals were removed, and that's how we get to that average. If we were to include those trees where we hit staining, there was about a 13% reduction in average sap yield when we hit that stained wood. So that's including the few trees in that where we didn't try to hit the old tap holes, but since they are large trees, have been tapped for a long time, we did hit some. Now, if we were to just look at the trees that were tapped above and hit stained wood, you would see a dramatic decrease. It was actually a 60% decrease in sap when you hit stained wood. Now, as you might imagine, the two treatments going below the lateral line, below and below with a check valve, there was no stained wood down there to hit, no tap holes below there to hit, so they didn't hit any. The important thing to remember is those first three treatments, there was no significant difference. So in other words, tapping below produced the same amount of sap on average, even if the bars are slightly different heights. The statistics suggest that there is no difference between tapping above and tapping below. Another interesting thing is the sap sweetness was no different between those treatments, and that's including the trees tapped above the lateral line with no stain, tapped below with a check valve, or those individuals that we hit where we did hit stained wood. They all had the same average sugar content, even though the bars are slightly different heights. The statistics are not significant. So in summary, we had two experiments on two very different weather years. 2015 had very cold with very deep snow. 2016 was warm and had very little snow. So we feel pretty good about this method under two different type seasons. There could be scenarios where tapping below may be more of a liability based on the weather, but we did not see that in our work. So no difference in sap volume, no difference in sap sweetness when tapping above, below, or below with a check valve. And it also had an experience of pointing out a significant impact on sap volumes if you were to hit into stained wood. And I have another talk that is available trying to do more on calculating the actual reduction when you hit stained wood. And look for that on the UVM Extension Maple website. There are some practical limitations that you need to think about. It may not be for everyone. When you tap below the lateral line, if you have a large snowfall late in the season, it could potentially cover up those spouts and it could potentially have an impact on sap flow. Also, frost heaving. If that drop line does not fully clear of sap and the sap freezes, you could potentially have spouts that are being pushed out of the stem. Another unintended consequence of tapping below the lateral line is that when you tap lower to the ground, there are more animals that can reach them. So we've actually heard of one producer trying this, and he found that coyotes were really interested in what these things were, and in one area of his sugar bush they were chewing up quite a few of the drop lines, and that was just because they could reach them much easier from the ground. So in conclusion, tapping below the lateral line, as long as you have good vacuum, doesn't have a big impact on yield. And there was some work done by my predecessor Tim Wilmot looking at 3/16 tubing and tapping below the lateral line, and I would recommend you check out his publications on that subject. Tapping into stained wood does result in a significant reduction in sap yield and should be avoided definitely at all costs. Now this is a good time to remind people that getting the highest number of tap holes in a given day during tapping may not be the absolute best thing to do, but getting the highest number of quality tap holes. So if you have people who are out there tapping and you find that they are hitting brown wood consistently, it may be time to slow everyone down, have them take a little bit more time looking up, looking at the whole tree, and really doing their best to avoid old tap holes. In general, we recommend that you try to go the opposite side of the tree from the previous year's tap hole, and that way really spacing out the staining. Tapping below the lateral line increases the sustainability and reduces the likelihood you're going to hit old stain by increasing the total size of that tapping band, essentially doubling the amount of tappable wood you can reach with your drop line. Sanitation impacts, and by that I mean contamination of sap in the tap hole, were pretty small and definitely didn't impact the yields clearly, because we saw no difference in yields. We're still working on the precise recommendations about how to orient the spout if sanitation is a concern, and stay tuned for more recommendations on that. Thanks for listening. If you have more questions about this topic or would like to check out the tapping zone model that I mentioned earlier, go to the UVM Proctor Maple Research website and search tapping guidelines. If you have other questions or want to talk to me directly, feel free to reach out, and my email is below. Thanks very much. Bye.